Here we go, lesson 1.5, scale diagrams. So great white sharks grow to a length of approximately 6.5 meters. The diagram is a scale drawing of a great white shark. To determine the actual length of the shark, we need to know the scale used in the diagram. A scale can be given in the following ways, as a statement. So 1 centimeter represents 0.5 meters. The statement tells us that 1 centimeter on the diagram represents 0.5 meters of actual length of the shark. As a rate, 1 centimeter to 0.5 meters, or 1 centimeter over 0.5 meters. This rate also tells us that 1 centimeter on the diagram represents 0.5 of actual length of the shark. Has a ratio of 1 to 50, and also has a line graph. So whenever you look at a map or a scale or maybe blueprints of a house, they should tell you the scale. So 1 centimeter equals 10 feet, or 1 centimeter equals 200 kilometers, etc. So the first thing we need to do that we'll need is to measure the actual length of a shark. Now, if you can find a ruler, it measures from the nose to the middle of there. So you can find an actual ruler, measure it out, pause the video, and then come back. Okay, so we measured the length of the shark, and if you wrote your answer down, it should be something like 9.6 centimeters. Now, if we're using the scale, proportional reasoning that we kind of learned, we can set it up like this. So 1 centimeter is over 1.5 meters is equal to 9.6 centimeters over x. So that's the unknown. We knew the original scale, and now we're setting up what we do know. The length of the shark isn't 1 centimeter, it's actually 9.6 centimeters. So what does that correspond in actual length? So if we cross multiply, we should get x times 1 is equal to 0.5 times 9.6, and x is equal to 4.8, and our units are meters. Okay, here we are into maps. So this is probably where you're more used to seeing scales. So here we have the first scale. Okay, 1 centimeter is equal to 75 kilometers. So it says use the graph to determine the approximate straight line distance between Calgary and Edmonton. So again, you can measure it. And where is Edmonton here? There it is, to Calgary, which is there. So if you measured it like I measured it, you get something like 3.6 centimeters. So again, we set up our ratio, 1 centimeter over 75 kilometers is equal to 3.6, which is what we know, centimeters, over x. That's the actual straight line distance that we're trying to find. So if you cross multiply, you should get x is equal to 3.6 times 75, and x then is equal to 270 kilometers. So that's the actual distance. All right, another map one. So here the scale, 1 centimeter equals 100 kilometers. So calculate the straight line distance between New Hazelton and Prince George. So the straight line distance between New Hazelton, which is there, and Prince George, which is there. So if you measure it, I think you get something like 3.4 centimeters. And again, you can verify this on with your ruler. So 3.4 centimeters. So we set up the ratio that we know, 1 centimeter over 100 kilometers, because that's what we got from the scale. Set that equal to 3.4 centimeters, which is what we measured, over x, the unknown, we don't know. Again, cross multiply, and we get x is equal to 3.4 times 100, which gets us 340 kilometers. Now, part B here, is the answer in A a realistic estimate of the actual driving distance? Well, no. If you look at the actual route, it kind of curves. So if we do a better measurement and measure the curvy parts, so this part, that part, and that part, you should get something a little higher, 3.6, 3.7, something like that. So the it's not an accurate estimate because the road curves. Simple. All right, last page. Tyler's scale diagram of a tower is shown. The actual tower is 240 meters tall. So write the scale Tyler used in statement form as a rate or as a ratio. So again, the first thing you need to do is measure how tall the tower is. So if we pull out that ruler, you should get something like 8 centimeters. Okay. Now if we take 240 meters and we divide it by 8, sorry, the other way around. Our actual length, remember actual goes on top, 8 centimeters over 240 meters. That reduces to 1 centimeter over 30 meters. So in statement form, 1 centimeter represents 30 meters. As a rate, 1 centimeter to 30 meters. As a ratio. Now ratio, you need same units. So we're going to convert 30 meters to centimeters. So we have 30 meters. We multiply that by 100. That equals 3,000 centimeters. So the scale is 1 to 3,000. Alright, Kylie from Abstract Renovations designs a plan for a candy store to be renovated. The scale drawing on the plan of the candy store is 1 centimeter to 50 centimeters. What are the actual dimensions of a storage room if the scale diagram dimensions are 8 centimeters by 12? So we set up our ratio. Let's deal with the 8 centimeters first. So 8 centimeters over x, it's the unknown, is equal to 1 over 50. If we cross multiply, 8 times 50 is 400. And then we do 12. So 12 over, we'll use a different variable, 12 over y is equal to 1 over 50. That's the scale that we got. Cross multiply again, and you get y is equal to 600. So the new dimensions are 400 centimeters by 600 centimeters. Sorry, this is the actual dimensions. So the scale was, the scale diagram was 8 by 12 centimeters, and the actual dimensions are 400 by 600. So if we convert this to meters, that's 4 meters by 6 meters. Okay. And part B, what are the dimensions of the plan if the dimensions of the chocolate section of the store are to be expanded to be 3.5 meters by 4.75 meters? So each of these dimensions you just need to multiply by the scale that we were given, which is 1/50th. So 3.5 meters multiplied by our scale of 1 over 50 equals 7 centimeters. And how I got 7 centimeters was I converted 3.5 meters to 350 centimeters first. And then you multiply by 1/50th and you get 7 centimeters. So the other one we need to convert 4.75 meters to centimeters, and we get 475 centimeters times our scale of 150 equals 9.5 centimeters. Okay, so the dimensions on the plan would be 7 centimeters by 9.5 centimeters. So that was just taking the scale of 1/50th and multiplying it by the new dimensions. So scale factor can apply to a bunch of different things: maps, drawings, diagrams, plans, etc. And the easiest way I find is setting it up in these ratios. If you have any questions, please see me.